So my name's Vesine. I'm a staff engineer at Datadog, and I wanted to say good afternoon. Thank you all for listening, even though it's late. I hear you're supposed to start talks with a joke, so let me tell you a joke. A QA engineer walks into a bar, orders a beer, orders null, orders -1 beers, orders 99999 beers, orders a lizard. First real customer walks into the bar, asks where the bathroom is, bar catches on fire, and everyone dies. Well, that's not good. So we're SREs. Let's do some root cause analysis. Let's write a postmortem and fix our system so that that doesn't happen again. Taking a look at the timeline of our incident, it's really clear that what went wrong is a customer asked where the bathroom is. We can resolve that issue by making sure our customers don't need to ask where the bathroom is. And we can do that by adding a sign. Problem solved. We've done all the right things. We analyzed our incident, we determined the root cause, we fixed it. We're really motivated SREs, so we wrote a document about how we could move the bathroom to an easier to find location in the future. We decided not to prioritize that this quarter. We'll get to internationalizing the sign eventually, too. So time keeps chugging along, and our bar business grows. We get some more customers who order more drinks, and we make more money. This is good. Sometimes our bar is really busy. The bartender gets behind for a little while, but they always catch up after a few minutes. I'm sure you've never seen services that do this. Until one evening, there's more customers than usual, and 2 customers try to order at the same time. And when that happens, the bar catches on fire and everyone dies. We seem to have an unreliable bar. Our previous method of finding the root cause didn't do the trick for keeping our bar from burning down, so our boss is unhappy with these results and suggests we use a formal analysis method like this 5 whys thing he's heard of. So like any good engineers, we get on the internet and we go to Wikipedia and we ask, how do you do 5 whys? And the Wikipedia article tells us that the technique is to ask why exactly 5 times to find exactly 1 root cause. You may have some criticisms of that, but for our bar, let's go ahead and use that original method, right? Let's just ask why exactly 5 times. Let's find the root cause. So let's do that. First, why did the bar burn down? Well, it's because our bartender got distracted. We want to stay blameless. It's important to keep our outage investigations blameless. So we want to ask why our bartender got distracted. What circumstances caused our bartender to be distracted? And we know that's because a lot of customers were ordering at once. And why were so many customers ordering at once? We had a demand backlog. Our bartender couldn't keep up with the demand. Well, why did we get a demand backlog? Obviously, we had a capacity shortfall, right? Our bar was more popular. We didn't have the bartenders to keep up with our demand. And why did we have this capacity shortfall? Why were there not enough bartenders? Well, as I mentioned, our demand is kind of surge related, and we don't have any kind of surge capacity for our bartenders. We have no way of adding a bartender really quickly. So clearly that's the cause of our outage. We need to have a way of adding surge capacity to our bar. Well, this is great. We found our root cause, and we can make our overall bar service more resilient by coming up with a way to schedule some kind of surge bartenders. We can maybe pay them only when they're actively working, so they're really elastic capacity. We can build an iPhone app, and we can leverage the gig economy, and it'll be really cool. We'll use Web3. We'll all get promoted for solving this technically complex problem. And we even use buzzwords, so definitely getting promoted. We only pay the bartender when they're actively pouring drinks for people. We're going to make even more money. And our bar has elastic capacity now. It's more reliable. We're not going to burn down again because we've run out of bartender capacity. So problem solved, right? Some time goes by. Our bar doesn't burn down. But as you've probably guessed from the slide, one night, something new happens. In this case, our bartender leaves the heat on overnight. And the bar catches on fire. Well, good news. This time, it was the middle of the night, and no one died. It's important, though, to analyze our near misses. I'm actually going to talk a little bit more about how to frame why it's really important to analyze our near misses in a moment. But our customers could have been impacted, and we just got lucky with the timing this time. Well, we've got this 5 whys tool. Let's try that again. Maybe let's try to dig into some different kinds of causes. Maybe that'll help us understand what's going on. So, why did the bar burn down? Because the heat was left on overnight. Again, we want to be blameless, but why did the bartender leave the heat on overnight? And it's because they didn't want to freeze to death in the morning. and it was a record cold night. Why was it a record cold night? Because of global climate change. Why is there global climate change? Well, the scientific consensus is that it's caused by the human use of fossil fuels, and at a high level, we use fossil fuels because of the pressures of capitalism. So, the root cause of our outage is global capitalism, and we can keep our bar from burning down by ending capitalism. I'm not quite sure how to do that in any sort of reasonable period of time. Yes, I suspect that ending global capitalism would keep our bar from burning down, or would let us keep our bar from burning down, but I don't think I can write you a project plan or an OKR for end global capitalism. So surely there's something else we can do. Surely there's some other problem that we can address here. So let's take a step back. Something's going wrong here with our incident analysis. I call this trigger whack-a-mole. Instead of finding the actual reliability issues in our system, the real root cause, we're just finding earlier triggers and trying to resolve those. And this doesn't work. There's always another trigger. There's always something triggering outages in our system. And when we do analysis that maybe finds a non-trigger, it's too big a cause to actually fix. The root cause of every production outage is the Big Bang. So I'll note at this stage that the Wikipedia article on 5 whys actually does reference a number of criticisms and shortcomings of the technique, that 5 is an artificial depth, that you're looking for a single root cause, and I think most importantly that it's not repeatable. It's really clear here that we're doing something wrong. We're asking the wrong whys. And in particular, I think that we don't have a good way to judge if the why we're asking is the right one, to tell people why this is the wrong why, or why this is not a useful answer to that why. And without a way of understanding clearly what we're searching for in our analysis, any method that we use to analyze our outage isn't going to help us. It's not about the method. It's about the skill. It's about the understanding of what it is that we're looking for. Let's look at a really simple model of our engineering world. This is the thing built on principles of system safety engineering. So we can divide the universe into our system and our environment. And the dividing line here is just what we can control. So for our bar fires, we've been focusing a lot of our analysis on things that are much more about the environment than the system. The things our bartenders do that they're not supposed to do, actions that our customers take, how many customers there are, the weather. We've been solving our problems within our system. By definition, our system is the place that we can control. It's the place that we try to do things. And in fact, one technique that we'll sometimes use when we're trying to fix our system, whether we do it consciously or not, is to find ways to move environmental factors from the environment into our system, to find ways to control those environmental factors with our system. So for example, when we have surge customers, we could hire a bouncer to keep our bar from having customers that come in all quickly at once, and instead to limit the rate of customers coming in. Classifying what's our system and what's our environment requires judgment. What are the things we control? What are the things that we don't? From Laura's talk, I believe, yesterday, understanding that the system includes what is its purpose, that's part of what you control, is relevant here. But we can be clear with ourselves about which way we've categorized something, why it fits there. And what we haven't done so far is to understand how the thing in our environment, which is our trigger, and that we by definition don't control, is actually interacting with our system to cause our outages. So here's how I think about this, again in the context of system safety engineering. We have our system, and in normal environmental conditions it works just fine. But there's some set of environmental conditions that are worst case. They're within our intended operating parameters, right? If we've said, if Godzilla levels a data center, we just go down, then that's outside of our intended operating parameters. That's okay. These are worst case conditions within our intended operating parameters that don't happen constantly. They're things like customers asking unusual questions, a sudden influx of traffic, it's really cold, things along those lines. At the same time, our system has some ways that it operates where under those normal environmental conditions, it all works just fine. But under specifically those worst case conditions, that vulnerability in our system results in an outage. In this case, we're having a fire. The goal of our incident analysis is to find the properties of our system that are interacting with those worst-case conditions and change our system so that it no longer has those vulnerabilities, rather than trying to account for specific triggers. This is the thing that you already know you want to do. I'm trying to help you articulate it. An important element is to find the parts of our system that have the potential to cause an outage, in isolation from whether they're being triggered. It doesn't matter if your outage has been triggered. You have an outage waiting to happen, a vulnerability in your system that you can fix. This is actually why it's so important to investigate and remediate your near misses. It's the potential for an outage that makes our system unreliable, not the existence of the trigger. One way to imagine is that, like I said, our system is just full of outages waiting to happen. The idea that we control the system and have to design for the environment is how safety engineering frames this problem. And it's a huge win for an SRE doing systems analysis. It lets you understand why it is that you keep seeing the same failure pattern over and over again with wildly different triggers. It's also why it's so important to analyze our near misses, because we can see where the vulnerability is without the environment being bad enough to actually cause the outage. So I want to take a second to talk about words. I've been saying root cause, and some of you have been very politely not shouting at me about what a terrible word that is. I agree. Root cause implies that there's a single factor leading to an incident. It's widely associated with choosing things that aren't systemic vulnerabilities, with just sort of going back in time to the most proximate thing. On the other hand, it's a term in very widespread use. If you would like to fight the good fight to get everyone to use different language, more power to you. I am too lazy for that, and I would rather redefine the word root cause as specifically the underlying vulnerability in our system. And that leaves trigger meaning the thing that makes the underlying vulnerability manifest into an outage. So we need to analyze what's happening within our system. With that as our guiding principle, what we're missing is what's starting the fire? How does this thing mechanically become a fire? How does bartender distraction lead to a fire starting? I'm still asking why. I'm really still using the same technique that I had before of asking why. But now I'm focusing on the system. How is the bar designed? What's happening inside the system itself? Not looking at my triggers and why did they occur, what's making the environment how it is, but what is making my system respond to the environment in the way that it is. So in this case, for our bar, turns out there's a heating system that overloads and it needs to be vented every few minutes. And there's a button behind the bar that we ask the bartender to press to vent the heater. I've never seen a system that looks like this. When our bartender forgets to press the button, sometimes the heat builds up and it starts a fire. So let's fix our bar. It's pretty natural to focus on pressing that button more reliably, right? We need to press the button. Pressing the button prevents the outage. We need to press the button better. Maybe we'd like to press it more often so that forgetting one or two presses doesn't start a fire, making a single distraction less of an issue. That still really relies on a fallible human. It's sort of requiring a human to do a bunch of toil to keep our system running. Let's build a button-pressing robot, right, to automatically press the button every 5 minutes for us. And then we've automated ourselves out of a job. That's the goal of SRE, right? But we've made our system more complex. We've now added a robot that can also fail. And when it does, our human is unlikely to remember how the robot worked and how the button worked, because humans are forgetful like that. Some problems, it is the case that the best solution we can build is a robot to press the button. But in a lot of cases, we need to ask, do we even need that button? Can we design our systems to not have this button at all? In this case, we have the button because our heating system overloads. Why does our heating system overload? What about our heating system allows for overload? Can we change the design of that system so that it isn't prone to overloading, so that it doesn't need manual intervention to keep from overloading? Although again, that often adds more components to the system, which are more things that can break. Fixing the overload flaw is going to be more expensive, right? Just adding a robot to press the button is almost certainly a cheaper solution. It's a Band-Aid, but it's cheaper. Notice how the button to vent, though, was already a Band-Aid over the fact that the heating system needed to be vented. So the heating system is prone to overloading. We add a Band-Aid that's the button. We add a robot to press the button. And every step of the way, our system gets more complicated and has more things that can go wrong. Can we trace back to why does the heating system overload? Can we make it not overload without adding more complexity? Sometimes you can't, but you should always ask. So another thing we can ask about our system is if when the bar burns down, we can just have fewer things go wrong. Can we keep from having anyone die? Can we improve our fire exits? Can we build in some kind of zone, some kind of fire break to make sure that that's not an issue? Can we make it not matter to our business? For example, have a second bar down the street, and when we have to evacuate our bar because it's burnt down, we can just send all of our customers to the bar down the street, and they can go drinking there. Maybe that's a good solution. Maybe it's just okay to be all right with our bar burning down once every few months. Again, I mentioned that what's in our system versus what's in our environment is a judgment call. Some things are really obvious, and some things sort of fall on a borderline, right? It's really obvious that my code, my testing, my capacity planning, those are kind of within my own system. Things that are always in the environment are things like machine failure, human error, the fact that we write bugs. Other things can be on a dividing line. For example, what infrastructure services I use, I may or may not have some control over. How I use those infrastructure services, what features they have. Maybe they're written by some other team. I could interact with that team and get them to change things. Maybe I can't. Sometimes you can manage your customer expectations. Sometimes you can't. Those things may or may not be within your system or environment. I'm not saying you don't have to do a bunch of engineering here. I'm trying to give you a framework for the engineering you're trying to do. And one final thing is that we can expand our view of our system to look at social elements, processes, cultural elements that lead to these problems. In this case, we might ask about the design of this overloading heater. What training did our designer have? What were the cost incentive structures that they were designing for? Were they trying for speed or labor or equipment price or maintenance? Were there heaters on the market that were the right kind and right size for our bar? Were they allowed to buy them? Was there a COVID-19 supply chain issue, and so that wasn't accessible at that moment? What was the permitting process for this design? What was the review process for this design of the heating system? Can we handle those things? Are we dealing with a corrupt city government that let us put in a heater that should never have been there in the first place? Or maybe an inspector who was hungover that day? I don't know, right? But we can look at those larger social processes. And as SREs in particular, I think it's really interesting that we start to ask questions about these social elements as we get more senior. Right? The system that we're trying to solve as SREs gets larger, and usually when our system gets larger, we start to have to ask about the people. And I think that that's a really interesting thing to think about as you become more senior SREs, although I know many of the people here are already very senior SREs. And that is my talk.